All right, we're on day 13, block 3. So today we're talking about one of the most important things with two variable statistics, something that you'll actually take with you throughout the rest of your life. It's the difference between correlation and causation. And when you look at like newspapers or you're on Twitter or whatever, if you guys even use Twitter, but anywhere you see people reporting statistics, you often see headlines like violent video games cause kids to be more angry or things like that. And you have to be really careful because a lot of people misreport statistics and claim that there's a cause between two things when really it's only a correlation. So you can choose, it's optional if you want to watch this 6-minute video. It's an interesting TED Talk, so it's a little bit more lively than I might be. You can watch that video first if you want. You don't have to watch it, but it is good, just extra information. But we'll go through everything you need to know here anyway. So a couple ideas to start this. So it says, a study found that the more hours students spend on activities outside of school, the higher their grades tend to be. Does that mean if you automatically sign up for more activities, your grades are going to go up just no matter what, just because you signed up? Another study found a link between how often you brush your teeth and a reduction in heart disease. Does that mean brushing your teeth causes your heart to be healthier? As a consumer of statistical information, you need to be aware of the difference between association, meaning correlation, and causation. Okay, you need to know whether two variables are just associated, meaning like related, or if one is directly causing another one to change. Okay, so this is going to look a little bit closer at that. So it says the mayor of Smallville finds the following graph in the town's annual financial report. So here's a graph. It's about the fires in this town. So here we have the number of firefighters at the fire and the amount of damage. It says describe the type of association you see in the scatter plot. So the correlation that I see, association, correlation, they're interchangeable. I'm noticing that as the number of firefighters increases, the amount of damage also increases. So that looks like it's about linear and positive, and I'd say moderate, maybe even weak, not super strong. The mayor immediately orders the fire department to send fewer firefighters to fight each fire, so there's less damage. So he looked at this and he said, okay, well, if we only have a couple of firefighters there, then there's less damage. So I'm going to stop sending firefighters. Do you think that's a good idea? No, this would be a really bad idea. He is confusing association and causation. He's mixing them up. They are correlated, but there's probably another reason why. So that other reason why these two variables are related is what we call a lurking variable. Lurking, it's like hidden in the background, kind of sneaking around. It's a hidden variable that is not part of the study. So for example, what hopefully came to your head was it has nothing to do with how many firefighters are there. It's about the size of the fire. If the fire is really bad, you're going to have to send a lot of people and there's going to be more damage. So that's another variable that's influencing both of the variables we were talking about at the beginning. Okay. Another example, it says a medical study found a strong link between the numbers of hours high school students wear a helmet and the number of head injuries or concussions that they get. However, it's unlikely that wearing a helmet actually causes head injuries. What do you think the lurking variable is? What's another reason kids are wearing helmets and having head injuries? So when I thought about this, I think of kids that are doing dangerous things. So maybe they're spending more time on bikes or skateboards or whatever other things you would wear a helmet to do that's also kind of dangerous. Or maybe they're playing sports. There's a lot of sports where you wear a helmet, football, lacrosse, and those often have head injuries. Okay, so it's not that the helmet is causing the head injury. There's probably some other variable influencing both things. Okay, So here's a web showing that example again. It can get complex and difficult to unravel if there's so many different associated variables. So for example, a medical study focused on hearing loss. It may associate variables like eating prunes to hearing loss when there's really no correlation at all. Looking at the web, what might be an actual cause for hearing loss? So you can see associations, causes. We're focused on hearing loss. What is actually causing that? When I look at this web, the only thing that's a direct cause connected to hearing loss is this word right here, here's cause, and it's connected to long-term noise exposure. The rest of the things are all just associated, or they're causing each other, but not necessarily hearing loss, like being a senior citizen, having gray hair. Gray hair cannot cause hearing loss, but it's associated with other things that might, okay? This next set, I don't really like this one, so I'm just going to talk through it. It's headlines from newspapers from actual studies. Each of them are claiming some type of association, and some of them even say there's a cause and effect, but let's think about other lurking variables. So I don't like this because you have to know a lot about some of these to think of another variable, so it's kind of difficult. Calcium in diet may cut risk for some cancers. So we're thinking, well, what else could be reducing the risk of cancer? Because I don't know if calcium is necessarily affecting that. So another reason might be like just being a healthier person. You might consume more calcium because you live healthier, and that also would reduce your risk of cancer. Another one, study family time declines as web use booms. So why would family time decline and website use goes up? Maybe families are more busy. I can think of an easy one. This current life we're living, people are on the web more than ever and probably spending a little bit less time together, even though you're home longer, but you're on the webs more because it's a pandemic and you're stuck at home, okay? We'll do one more and then we'll be done with this. So chocolate's linked to depression. Now that's one you hear a lot, but that might not cause depression. Maybe people who are already feeling sad or having some issues eat more chocolate. So feeling sad is maybe the lurking variable causing both of those things. That is spelled totally wrong. Chocolate. Okay? Right, so lurking variable is just another variable impacting the two things that you're already studying. So lastly here, we'll look at scatter plots again. We've talked about this before, this first part. Positive correlation, negative correlation. And sometimes there's no correlation. That would be nonlinear. So here's our examples, positive, negative, and this one is no correlation. Okay, positive correlation, negative correlation, or none. Pretty much relates directly to whether it's linear or not. But the new piece is down here. It's called the correlation coefficient. I'm sorry this is so blurry, but do your best. It's the letter that it gets is R. So remember in that, when we did lin reg on the calculator, you had y, a, b, r squared, and r. Whoops, not r squared again, just r. This is the one we're talking about, whatever number is at the bottom here. Okay, that tells you how strong the actual correlation is. So if r is equal to 0, so if that number is equal to 0, which it's usually not, but if it's equal to 0, that means there's no correlation. As it gets closer to 1, it becomes a positive, strong correlation. It will never go above 1. 1 is the highest it can be. But if it's like 0.5, that would be a really weak relationship. If it gets really close to 1, that's really strong. On the other hand, -1 would be a strong negative relationship. Something like -0.3 would be really weak. Okay, so you're looking for that R value to be close to 1 or -1 to say, oh, that's a really strong correlation there. So let's do some examples. each scatter plot, tell whether it has a positive correlation, negative correlation, or no correlation, and then determine which number is closest for the correlation coefficient. So the calculator would give you the exact one, but here we're just picking one of these options that most closely represents this data. Okay, so when I look at that first one, let's start with just our correlation. So this looks to be a positive correlation. If I were to kind of sketch my line of best fit, it might look something like that. So it's going up. And I wouldn't say this is a super strong relationship. The dots aren't that close, but it is positive. So I have to pick the positive number. I'm gonna pick 0.5 for my options. Remember, 0 is no relationship. 1 is like the most perfect straight line of dots you've ever seen. Okay. Number 2, whoa, that's a bad line of best fit, but you get the idea. That's a negative. So it's going to be one of my negative options. This looks very strong. They're really close together. So I'm going to say -1 here. It might really be more like -0.99 on the calculator or -0.98. You're not going to ever see -1 on your calculator. Not in real data, that doesn't happen, but it's really close. And the last one, I don't see any way I can draw a line of best fit here. So this would be no correlation, meaning my R value is 0. I should say equals R, sorry. Okay,